invert binary tree, and I'm going to do it in Ruby. Basically, you start with the root. You're given the root of a binary tree. Invert the tree and return its root. So we start off with this tree, and the root looks like this, and we want to invert it so that the 2 is now where the 7 is, and the 7 is where the 2 was, and all of its subtrees as well. And other examples, just a really simple tree, and it takes this root, and then the left and the right, you swap those. And then the output is different from the input right here, and if it's just empty, then just return empty. So in that case, that is just empty, so you could do if not root, then return root. And then I'm going to try a recursive solution first, and then an iterative one using a while loop after. But the recursive one would take first we'd want to swap this current roots left and the right, so we could do the temp variable one where it's root dot. So temp is holding on to our root left's value, and then root dot left is equal to root dot right. We're going to be swapping left with the right, and then root dot right is equal to temp, what was previously holding on to our left one. Now we are normally going to, at the end of it all, you're going to want to return the root, because it has it's like that handle top of the head kind of thing. But first you're going to want to call invert tree on the left side that you just swapped, and invert tree on the right side that you just swapped, because those each have the subtrees. And then afterward that, it's going to continue to call invert tree recursively, and then it's going to swap from 9 and 6. And if those don't have a left and a right, it's still going to swap them, but I'm sure those values would be nil. But at that point, you would invert tree of those left and rights, but then you'll find out that those are actually nil, so then that returns the root, and then it'll keep on climbing back up the recursion stack. So invert tree root dot left, invert underscore tree root dot right, and then at the end you're going to want to return root. And then all the way at the end, when you're back at the bottom of the call stack in the very first call, you're just going to return the root. Let's just see if this passes the small test, and then submit. And yeah, this one passes. So that's the recursive one, and then I'm going to do the iterative one using a while loop. It's the same idea, except we want to use a queue or a stack. I'm going to use a queue and shift the first item off of it. If we were to use a stack, we would pop the last item off of it, as we're going one by one. But queue, now we could queue push the root, because from this queue, the first item that we want to work with is the root, because that 4 has the handle. While queue.length is greater than 0 and then I learned in Ruby that just doing while queue.length is not going to stop the while loop. 0 is truly in Ruby, so you have to explicitly say while queue.length is greater than 0. Otherwise you could do an until queue.empty. You could do one of those, but I'm going to stick with the while loop. And so while this queue still has a length, go through it, and you're just going to want a current pointer that is going to always be loaded up with the queue.shift, the first item that was taken out, removed from the front of the queue. And that's the item we're going to use and observe. So current, then we would do the same thing. Temp is equal to current.left. We're looking at the current's left. Current.left is equal to current.write, and then current.write is equal to temp. And since we've swapped it once now, and it kind of looks like this, 4, 7, and 2 right now, then we're going to want to load up the queue with these newly swapped nodes if they exist, because remember at some point when you get like down to here, it won't have a queue, it won't have a current or roots left and a right. In that case, you don't want to fill up the queue with null or nil values, because that's how it's going to throw errors saying like there is no left property of value nil or right property of nil. So we can load up the queue on the basis that it actually has a left property or a right property. Left queue.push current.write if current.write, and that'll push 7 and 2 in for instance. Yeah, so we had 4, and then we shifted 4 out, and then we swapped, and then we'll have 7 and 2. So then we have 7 and 2, and then we'll keep going, and then we shift out 7, and we swap out the 9 and the 6, so then 9 and 6 are loaded up. Then we work on the 2, so 2 is shifted out, and then we swap those 2, and then 3 and 1 come afterwards, and then you shift out the 9, you start working on the 9, you shift its left and right, which both of those are just nil, and then it doesn't push anything because there's nothing there. Then you do the same with the 3, there's nothing there. Then you go with the 3, the same thing, there's nothing there. Then you go with the 1, same thing, there's nothing there. So now queue length is not greater than 0. So when we finally pop out, we want to just return root, or in Ruby you can just do that. And then I'm going to run that, and that passes the small one, and then okay, and that passes that one.